Welcome to a session on Einstein coefficients. In a collection of atoms, all three transition processes occurs simultaneously, which are absorption or stimulated absorption. These are upward transitions, and spontaneous emission. This is downward transition, and stimulated emission. This is also downward transition. So these three transitions are simultaneous in the atomic process. So now let us consider N1 is the number of atoms per unit volume with energy E1. Similarly, let us consider N2 is the number of atoms per unit volume with energy E2. Let us consider U of nu as the energy density of the interacting photons. When these photons interact with the atoms, both upward as well as downward transitions occur. Upward transition. Stimulated absorption is the one of the upward transition. So the stimulated absorption rate equal to N1 U of nu into B12. Here B12 is the Einstein coefficient of stimulated absorption. Let us see the downward transitions. Actually there are two downward transitions. One is spontaneous emission and another one is the stimulated emission. By spontaneous emission rate is N2A21. Here A21 is the Einstein coefficient for spontaneous emission. Similarly, for stimulated emission, the stimulated emission rate can be calculated as N2 into U of nu into B21. Here B21 is the Einstein coefficient for stimulated emission. Under thermal equilibrium, number of upward transitions equal to number of downward transitions per unit volume per second. So, number of upward transitions are, what are upward transitions? Upward transitions are the only absorption. Downward transitions are emissions, either stimulated emission or spontaneous emission. So, by equating those two rates, we will get N2 A21 plus N2 U of nu into B21 equal to N1 U of nu into B12. Here N2 A21 is spontaneous emission rate and N2 U of nu into B21 is the stimulated emission rate equal to N1 U of nu into B12. This is the absorption rate. So this is the upward transition and these two are the combination of downward transitions. So by rearranging this equation, we will get U of nu equal to A21 by N, A21 into N2 divided by B12 N1 minus B21 N2. Dividing by B21 N2 in all terms, U of nu equal to A21 divided by B21 into 1 divided by B12 N1 divided by B21 N2 minus 1. By substituting N1 by N2 as exponential of h nu divided by kt from Boltzmann distribution, the above equation will be termed as U of nu equal to A21 divided by B21 into 1 divided by B12 B21 into this N1 by N2 can be written as exponential of h nu by kt minus 1. Above equation must agree with the Planck's energy distribution radiation formula. U of nu equal to 8 by h nu cube by c cube into 1 by exponential of h nu by kt minus 1. Comparing equations 4 and 5, we will get B12 equal to B21 and A21 by B21 equal to 8 by h nu cube by c cube. So the coefficients A21, B12 and B21 are known as Einstein coefficients. And these are the relation between Einstein coefficients. One relation is B12 equal to B21 and another relation is A21 by B21 equal to 8 by h nu cube by c cube. Thanks for watching.